3.2 Mass-energy relationship. Let's begin. Missing mass. The very famous equation from Einstein, E equals mc squared, suggests that energy and mass are interconvertible. In fact, scientists have found that mass disappears to create energy, and energy may also turn into mass. 1. Mass-energy equivalence. In his special theory of relativity, Einstein suggested that mass and energy are equivalent and interconvertible. In the equation, delta E is the energy produced when the mass of delta M, also called mass defect, disappears, and c is the speed of light. As c is large, a small mass delta M may be converted to a great amount of energy. Example 4. The mass-energy relationship. In this example, a Hong Kong 10-cent coin is converted completely into energy, which amounts to 1.67 times 10 to the power 14 joule of energy, which is more than the daily electricity consumption of all households in Hong Kong. 2. Energy released in nuclear reactions. In fact, when there is energy change, there must be mass change. This is true for all cases, including chemical reactions, as well as nuclear reactions. But your science teachers in the past said that there is conservation of mass and also conservation of energy. Are they wrong? Conservation of energy and conservation of mass are practically correct in most cases, because the mass change is usually so little that secondary school laboratory can never measure. So it would be okay to say conservation of energy and conservation of mass unless the energy change is huge, as in the case of nuclear reaction. A. Atomic mass unit. So even a $1 coin or a 10-cent coin can be converted into huge sum of energy. In this sense, gram is already too big to measure mass change. In nuclear reaction, mass is expressed in terms of atomic mass unit, U for short, which is just 1/12 of the mass of a carbon-12 atom. So 1 U equals 1.661 times 10 to the power negative 27 kilogram. In the following table, you can see the mass of an electron is a little bit larger than a proton. Now try to find their difference using a calculator. You will find the difference to be 0.001389 U, which is much larger than the mass of a single electron, 0.000549 U. Why? You will know the answer when we study beta decay. B. Mass difference and energy. In nuclear fission and fusion, the product is usually more stable, and so the total mass of the product is usually smaller than the reactants. The loss in mass is converted to energy in the form of electromagnetic wave or kinetic energy of the products. For a typical fission of uranium-235, the loss in mass is 0.192789 U, which is converted to energy 2.88 times 10 to the power negative 11 joules. For convenience, the energy released in a fission of uranium-235 can be expressed as 2.88 times 10 to the power negative 11 joules, or 0.192789 U. In other words, you may express nuclear energy in atomic mass unit. You may notice that a large release in energy means the product is more stable. The energy released when a nucleus is formed is called binding energy. For details, read the supplementary information on page 103. By the way, another common unit of energy used in atomic scale is electron volt, and 1U equals 931.5 mega electron volt. We will come back to this in Book E2, Atomic Physics. Example 6. The energy released in nuclear fusion. As energy is released in nuclear fusion, the total mass of the product of the reaction must be smaller than that of the reactants. So you have to find the total mass of the two sides first, and then find the loss in mass, and lastly convert that into energy. Example 7. Exploring the moon. For that question, take special care to part C. One advantage and one disadvantage of using helium-3 as a fuel for fusion. For the advantage, we know it is highly efficient. That means the energy density of helium-3 is very high as a nuclear fuel. And for disadvantage, it is difficult to obtain, as it is rare on Earth. Example 8. Nuclear power. Take a look of part C. Give one advantage and one disadvantage of using nuclear power. Talking about advantage, nuclear power may be a solution for energy crisis. And for disadvantage, remember that the waste products and byproducts, they are all highly radioactive that may bring about environmental and health issues. And sometimes we talk about spent fuel, which means the fuel that is used already. So talking about the products of fission, which are the barium, the krypton, the medium-sized nucleus, and usually they are radioactive. And now please do check point 3.